Welcome, Cosmic Voyagers, to Cosmic Enigma, your portal to the universe's most profound mysteries. Hey, space explorers! Ever gazed into the velvet abyss of the night sky and felt that primal urge to ask, are we truly alone? What if I told you that our closest planetary neighbor, a world we once dismissed as a literal, fiery hellscape, might actually be harboring a secret so profound it could shatter our very understanding of life itself? Buckle up, because today, we're plunging headfirst into the heart of the Phosphine controversy on Venus, a scientific saga that could redefine our place in the cosmos. For eons, Venus has been the cosmic wallflower in the grand search for alien life. I mean, who could blame us for overlooking it? We're talking about a planet with surface temperatures hot enough to melt lead. Seriously, nearly 900 degrees Fahrenheit, or over 470 degrees Celsius, and an atmospheric pressure so crushing it would flatten you faster than a pancake. Not exactly a five-star resort for living organisms, right? Most astrobiologists were busy scrutinizing Mars for ancient water, or dreaming of the icy subsurface oceans of moons like Europa and Enceladus. Venus, shrouded in its perpetual sulfuric acid clouds, seemed utterly inhospitable. Its atmosphere, a dense blanket of carbon dioxide, traps heat in a runaway greenhouse effect, making it the hottest planet in our solar system, despite being further from the sun than Mercury. The very notion of life thriving there seemed absurd, a fantasy reserved for the wildest science fiction. Yet the universe, in its infinite wisdom, often delights in defying our expectations. Then, in September 2020, the universe threw us a curveball that sent shockwaves through the scientific community. A team of intrepid astronomers, led by the brilliant Professor Jane Greaves, dropped a bombshell. They had detected a mysterious gas called phosphine, pH 3, chilling out in Venus's relatively temperate upper clouds. This wasn't just any gas. This was a potential game changer. Now hold your horses, because this is where the story gets truly wild. On Earth, phosphine is a super stinky, highly toxic gas. But here's the kicker, the crucial piece of this cosmic puzzle. It's almost exclusively produced by two primary mechanisms. One, industrial processes in factories. And last we checked, Venus isn't exactly an industrial powerhouse with smokestacks belching out chemicals. Two, and this is the big one, by anaerobic microbes, tiny, funky organisms that thrive in environments utterly devoid of oxygen, often in swamps, guts, or deep-sea vents. The truly bizarre part, Venus's atmosphere, while dense, is also highly oxidizing. This means that phosphine, if introduced, should be obliterated almost instantly by reactions with sulfuric acid and other atmospheric components. So finding it there, especially in the significant amounts they did, was like stumbling upon a polar bear sipping a smoothie in the middle of the Sahara desert. It was a potential biosignature, basically a chemical whisper, a tantalizing hint of possible life. The scientific community, as you can imagine, went absolutely bonkers. Professor Jane Greaves, the rock star who led the team, famously exclaimed, "When we got the first hints of phosphine in Venus's spectrum, it was a shock. They had used some seriously powerful telescopes, the James Clerk Maxwell Telescope, JCMT, in Hawaii, and the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, to catch a faint dip in the light passing through Venus's atmosphere. This dip was phosphine's unique chemical fingerprint, its spectral signature, a specific wavelength of light it absorbs." Their methodology was meticulous. They played cosmic detective, painstakingly ruling out every single non-biological suspect they could conceive of. Could it be volcanoes erupting? No, volcanic activity on Venus doesn't produce phosphine in these quantities. What about lightning strikes? Unlikely to generate enough. Meteorites burning up in the atmosphere? Not a plausible source. Even plain old sunlight interacting with atmospheric chemicals? Nope, nada, zip. Nothing known could explain the persistent presence of phosphine. The only known explanation left, the one that sent shivers down the spines of astrobiologists, was, drumroll please, life. But here's where the plot thickens faster than Venus's atmosphere. Extraordinary claims demand extraordinary evidence, and the scientific world has its own ultimate fact-checkers, rigorous peer review. Immediately, other brilliant minds, driven by healthy skepticism and the pursuit of truth, began poking holes in the data and the interpretation. This isn't a sign of weakness in science. It's its greatest strength, its built-in self-correction mechanism. The main beefs raised by critics were twofold. Some argued that the faint phosphine signal might just be a data processing artifact, basically a digital ghost or a cosmic mirage created by how they cleaned up and analyzed the raw telescope data. Imagine trying to find a tiny needle in a haystack of cosmic noise. Sometimes, the way you sift through the hay can create illusory needles. Others whispered that it could be an imposter gas, a misidentification of sulfur dioxide, SO2, a common and abundant gas on Venus whose spectral signature, at certain resolutions, can be a little too cozy with phosphines. Could the signal they saw actually be SO2 masquerading as pH3? To their immense credit, the original team didn't just shrug off the criticism or retreat. They embraced the challenge. They went back to the cosmic drawing board, reanalyzed their data with a fine-tooth comb, and guess what? They still found phosphine. The signal was a tad weaker in their reanalysis, suggesting slightly lower concentrations than first thought, but it was stubbornly there, with strong statistical confidence. This whole scientific back and forth isn't a sign of science failing. It's science flexing, constantly questioning, testing, and refining our understanding. It's how we get closer to the truth, even if it's a messy, exciting, and sometimes contentious journey. This iterative process, where hypotheses are proposed, tested, challenged, and refined, is the bedrock of scientific progress. It ensures that only the most robust findings withstand the crucible of scrutiny. The persistence of the phosphine signal, even after intense reevaluation, only deepened the mystery and heightened the intrigue. It suggested that something genuinely anomalous was occurring in Venus's clouds. Just when you thought this cosmic soap opera couldn't get any wilder, a new twist emerged that felt straight out of a sci-fi movie. In 2021, a different team of researchers decided to play cosmic archaeologist, digging through old, dusty data from NASA's Pioneer Venus probe, a spacecraft that actually flew directly through Venus's atmosphere way back in 1978. This was an in situ mission, meaning it took direct measurements from within the atmosphere, not just remote observations from Earth. And what did they unearth from those decades-old archives? Hints of phosphine at even higher concentrations than the recent ground-based observations, lurking in that vintage data. This independent confirmation from a historical direct sampling mission makes the phosphine mystery even more compelling. It suggests this isn't just a recent fluke, a transient event, or a modern observational error. It might be a persistent, long-standing feature of Venus's atmosphere. Talk about a cosmic cold case suddenly heating up, adding layers of historical depth to an already perplexing puzzle.
So what's the next move for Venus, this enigmatic twin of Earth?
The only way to truly solve this mind-bending puzzle, to definitively confirm or refute the presence of phosphine and its origin,
Is to get up close and personal, to literally go there and sniff out the truth.
And guess what? The world's leading space agencies are totally on board. They are transforming Venus from a forgotten, hellish world into the hottest new destination for astrobiology and planetary science. Missions like NASA's Da Vinci Plus, Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, will send a probe directly into Venus's atmosphere, descending through its layers to take precise in situ samples and measurements. This will give us unprecedented, in-your-face data about the atmospheric composition, including the presence and distribution of phosphine. Others, like NASA's Veritas, Venus Emissivity, Radioscience, INSAR, Topography and Spectroscopy, and ESA's ENVISION, will orbit Venus, mapping its surface with radar to understand its geological history and current volcanic activity, helping to determine if volcanoes could secretly be brewing the gas. India's Shukrayan-1 will also be joining the phosphine hunt, carrying instruments designed to study Venus's atmosphere. It's an absolutely thrilling time for Venus exploration, a new golden age of discovery.
So, what's the final verdict in this cosmic whodunit? Is there alien life floating in Venus's clouds, defying all odds, thriving in an environment we once deemed utterly impossible? Or is there some incredible, mind-bending, unknown chemistry at play? A novel geological or atmospheric process that we simply haven't discovered yet? Both possibilities are utterly jaw-dropping, each carrying profound implications for our understanding of the universe. If it's life, it means life is far more resilient, adaptable, and ubiquitous than we ever imagined. It would mean that life can arise and thrive in environments we previously considered uninhabitable. Pushing the boundaries of our definition of habitability? It would rewrite our biology textbooks, forcing us to reconsider the conditions necessary for life to emerge and persist. Imagine extremophiles not just surviving, but flourishing in sulfuric acid clouds. If it's unknown chemistry, it means our understanding of planetary atmospheres and geochemistry is seriously incomplete. It implies there are new, unexpected chemical pathways and reactions just waiting to be discovered, processes that could be occurring on other planets throughout the galaxy. Either way, my friends, whether it's life or a revolutionary new understanding of chemistry, we win. The boundaries of our knowledge will expand dramatically. The Phosphine mystery on Venus is a perfect example of how science isn't just about finding definitive answers. It's about the incredible questions that push us to explore further, to build better instruments, and to challenge our preconceived notions. It's a thrilling cosmic detective story, and we're all on the edge of our seats, waiting for the next chapter. What do you think is causing the phosphine? Is it a sign of life, or a chemical enigma? Let us know your theories in the comments below. If you loved this deep dive into one of the universe's most captivating puzzles, hit that like button. Share this video with your fellow space enthusiasts, and don't forget to subscribe to Cosmic Enigma for more cosmic adventures and mind-bending scientific explorations. Thanks for watching, and as always, keep looking up.